This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Hey, this is Jeremy Jung for Software Engineering Radio, and today I'm talking to Moji Sarooghi. He's a distinguished project architect at Qt. Moji, welcome to Software Engineering Radio.
Hello. Nice to be here. I'm product architect, just to be clear.
Oh, product architect.
Yes.
Okay.
Sure.
And I think what we should start with, because a lot of people won't be familiar with what Qt is and what it does, what's a virtual waiting room?
When there is a traffic spike on a web server, what we do, we get that traffic, and then based on some flow that our customer sets, we redirect back those visitors to the customer website. Actually, what we call it is more like a traffic management tool that we have. But what will happen under the hood, or what is visible for our visitor, is that when there is a ticket sales or there is a specific product drop, there are a lot of people interested on that product. So they go and try to buy that product. Imagine it could be a new iPhone release or really interesting singer that wants to have a new concert. So the website announced that there is the sale at this time. A lot of people will go and try to buy that one. We get the first hit. We show a good user experience to the visitors and give them a fair user journey. We redirect back traffic to the customer websites, and they can buy the ticket or product that they are interested in.
And would this usually be where your customers would always have Qt in front, or would it be where the customer decides, oh, I'm going to have this high traffic event, and then so I'll only use it in these situations?
Yeah, we have two different scenarios. We call it opening scenario. In the opening scenario, we will set up and say that the waiting room will start at this specific time. So the traffic, not at that time, will go directly to the origin, which means all the product pages and all the resources are accessible. At that specific time, the traffic will be redirected to us. We have another scenario, we say 24/7 protection, or we call it safety nets. In the old name means that always traffic will be going through flow protection. So if suddenly one of the customers, without knowing it, that there is a specific sale time, so there is a social marketing goes and put a post in the social network, suddenly there is a surge of traffic coming to the website. We also monitor that one. So opening scenario versus 24/7 protection.
Because for the second case, something that I've been experiencing a number of times is where a website that sells something, they put up a popular product, and the time they put it up, you go to the web page and it just hangs or doesn't load, and people are all trying to refresh the page or wonder if they're going to get in, and they're trying to put stuff in their cart and they're getting error messages. So that's what this tries to avoid.
Exactly. That is the case. So how we kind of like talk about ourselves is that there is two reasons here. The first one is that we want to give a good user experience to the visitors. And that good user experience come by because of the scarcity. The nature of the product is that you have 10 or 100 items in the stock. So how do you want to sell those? Whoever comes fast, and in the internet for fast does not make sense. Am I closer to the data center so I'm fast, or the other one is fast? So what we do, we go for the opening scenario. Everybody comes, they get randomized, get a place on the waiting room. So it's a kind of like a fair user journey. The other scenario, as you mentioned, is that I just put it there and then my website does not respond in the right time. So that is also a good, still we are talking about the good user journey in both scenarios.
So I imagine each scenario is a little different in how Qt handles it. Out of the two, which one do you think we should start with? I want to walk through what happens when a user goes to the site and then how that flows through Qt's architecture.
From the technical perspective, both of them are the same almost, just the opening is different. So we can start by the scheduled waiting room. I think that has something extra than 24/7, which is opening time.
Okay, so let's start with that. Let's give an example of you've got a big event, whether that's a big concert or a conference that's really popular. And let's say there's a time that it's scheduled to start. I go to the ticket selling page. What's happening with Qt and my connection?
Sure, I get also a little bit technical in this one. What we have a piece of code, we call it connector. That code has a responsibility to look at the request context on that specific add to cart or visiting that specific ticketing page. What will happen? A visitor make a request to the backend, and this connector code is running on the customer website that could be sitting on the edge, which is CDN, and we use edge compute. We call it edge worker. So that calculation or compute will happen on the edge, or could be on the customer website. That could be a PHP server, .NET server, or Java server. And in each language, we have this connector. What does it do is that look at the request, look at the context. When I'm saying context, it's clear. It could be cookie, header, or all the other information related to the HTTP GET or POST. If the request says that this specific visitor has not been in the waiting room, what we do a redirect to the waiting room as a 302 response. And then the visitor will see a page of the waiting room is presented to them. And at this stage, what we do is that we design the page in a way that is look like the brand that you are seeing. So you don't see that, oh, I was buying a ticket, now it's totally different page. So it's customizable page. And then what will happen in the opening scenario that we are discussing, you get a GUID as your queue ID, means that you have that ticket and you are waiting with the other one. Still, the waiting room is not open. Imagine that the waiting room is open at 9 and now it is 8:30. So we will wait here until all the other people come. It's like you can imagine of a shop that all the people come and stay in front of the door. Door is not open yet. The time that the door wants to open, we do a raffle or, we randomize based on a specific algorithm. And then to each queue ID, we give a queue number, which gives you a place on the waiting room. Then this page that is generated, there is a pooling mechanism. Again, little bit technical. It's just HTTP GET, give me what is my place in the waiting room. Now we know what is your place because the randomization has been done. We show you that your place in the waiting room is number 100, for example. How many people in front of you? We know what is the outflow of the waiting room per minute, how many visitor we can redirect. This value is set by a customer. So based on that one, based on your place in the queue and based on the outflow number, we can calculate and show approximately when is your turn and you will be redirected. There is some details here. Somebody might leave the waiting room, so there is a no-show, and then this number will be calculated, but it is a good estimate that what will happen. So one can put the phone on the pocket and then go and say on 30 minutes later, that will be a turn. They open up. What we show is that now is your turn. At this stage, we redirect back to the customer website with a specific token that is hashed by us. And then that token or session is showing that this specific visitor has passed the waiting room. And then we let the call to the origin happens now. So you can purchase the tickets. That is like the flow of the opening scenario.
Okay. So to summarize, you are looking at certain things that determine whether or not this user should be allowed into the waiting room. And then you give them a random GUID and you basically wait until the actual starting time of when people can buy tickets. You randomly assign them a place in line, and then you manage that line until once the user gets to the front of the line, then you send them to the user's system or the customer system so that their system can process the actual sale. So I want to talk a little bit more about that first step. When you say you're trying to determine if this person should be allowed in, what are some of the things that you're looking at to determine whether they should be or not?
Yes. In the first part that I mentioned, what we do is that we send another token from the customer website to Qt, and that token is hashed by our connector. So our connector knows that this specific visitor, when you make the first request, that will be a redirect to Qt carrying that token. So there is a token in and there is a token out. That is one way of setting up this. We have another type of a waiting room. We call it invites only, or kind of like a VIP waiting room. In those kind of waiting room, people start their journey by a specific link that issued by customers. So it's like imagine it's a Black Friday, customer has a loyalty program. They have a list of their loyal customers. We call them visitor, but for our customers, they are their customers. They issue a specific link for them, and we let whoever has that link come and join the waiting room. Also, we have something in place that says every key can get just one QID. So people also are limited not reuse their tickets when they join to the waiting room.
In that first scenario, you were saying the customer site sends you a token. So it sounds like in that scenario, before the user gets to queue it, they would be going to the customer site directly, getting this token?
Yes.
Okay. So that would mean that the customer site needs to be able to handle at least this initial load.
Exactly.
I got it.
Yeah, you are pointing to the right thing. And exactly that is the point that I'm mentioning. If you use, for example, Edge connector, actually is not the customer website that getting the first hit. It is the CDN, and CDN can handle quite a lot. And also in the scenario that our connector is set up not on the edge, but on the origin, at this stage, still, although the website get the first hit, but the first hit is not touching any database or anything like that. The logic is pretty simple on that scenario. It says that, okay, you get the call, it is protected, issue a token, redirect to the queue. So it's not a heavy computation from that regard.
And so this example where they go to the customer's site first, you're saying that they integrate a library or a piece of code from Qt, and that code is actually what's making the determination that this is a valid user or not.
Exactly.
Okay. So it's the origin needs to handle it, but that check is it's not resource intensive. So hopefully, as long as you have enough compute power, you should be okay.
Exactly. And this, the whole process, again, in the scenario that it's open, we are talking about scenario that sales is open for everybody, or the person has been logged in the system, and this does not happen on the peak because, the login process is kind of like a distributed on the time. So this is pretty simple calculation, adding some kind of a key and then redirected to Qt. Even we have another layer, another way of integrating. If you are doing on the CDN, that was a kind of like, it's like a Akamai Edge worker or Cloudflare workers or AWS or Fastly. This is a pretty high capable CDN. So origin does not get even the first hit. The first hit will happen on the edge. And then we even do not call that calculation or compute that I mentioned does not happen on the customer website. It will happen on the edge.
I see. And that's the customer's choice in terms of they can choose one of these cloud providers to run this initial check on.
Exactly correct. Yeah. And also we really recommend the edge computes because we believe that this is also the future from the security perspective, from the load perspective, and also from the maintainability perspective. Yeah, this piece of code that I'm writing it, for example, in C# and give it to the customer is hard. You need to open up the server, and some of our customers have, 500 developers that's maintaining that server. So it would be really hard to go and tell them that, okay, please put it on the action, for example, for this add to cart. But when we put it on the edge, there is this decoupling between the origin and Qt code, which is pretty neat from that perspective for maintainability.
And that piece that's running on the edge, is that a piece of code that you provide to your customers?
Exactly. That is, we call it connector. It's a SDK code. It's not a complicated code. Yeah, it has a couple of if then else, what path I need to look up because, maybe at the day that we are protecting one show, we don't want to protect the other show. So we need to do a path matching and then also evaluation of those hashes that I mentioned before. So that is a pretty lightweight code that can run almost everywhere.
And what is that written in? Is that JavaScript or something that's kind of commonly available?
Yeah.
Okay.
You have a point on that one. Yeah. It is when we are talking about the edge ones, it is mainly JavaScript. Now also we are seeing a little bit of the WASM part as well, also getting popular, but almost all the edge compute technology, at least 4 of them that I'm mentioning, Fastly, Akamai, Cloudflare, CloudFront, all of them support the JavaScript one in different architecture, but at the end, the code is the same. If we are talking about the origin one, it is written on the languages that the origin runs. So if there is a customer that's running C#, it is written in C#. If it's Java, it's written on Java. So the important here, again, not specifically related to Qt, but this connector, the piece that we need to put on the customer website or on the edge should be easy to integrate. That will speed up the whole onboarding process, which is pretty important.
You can either choose to run this connector, this check for valid clients on the edge, in which case it's JavaScript, or they can run it on their origin. And it sounds like you have a number of different languages that you've provided. Let's say we get past that point. We've done this check. Now we're in the waiting room as a customer. What service of Qt are we interacting with? Are we polling something to see what's going on? What's that part look like?
Yes. Now this page is generated. That is an HTML page. We use CDN to have the static resources for ourselves as well. Now we are talking about CDN in front of. We have a WAF in front of our services, to do a DDoS. On the backend, we call those services visitor-facing services. So we created we can say a small microservices to be able to answer these requests from the visitors. And these services they are part of those highly reliable services and scalable services, because they are the main part that will respond to the visitor requests that can be a couple of million per minute. I'm talking about 50 million, 60 million, 100 million during the peak time, which maybe not all real users, maybe 90% could be bots as well, but they are the main parts. What we do here, the first request is a page get. So the get request, if it understands that there is a queue scenario, we need to visit, show or render this HTML page. And then after that, we need to have some kind of call that give the visitor a state of where he or she is in this waiting room, and then update the information. We have also capability of the customer putting some kind of information to show, a stock is done, or wait please, we are still selling in this product, and all those stuff. So we have 3 different things here. First, we need to assign a queue number, do that calculation, give them a QIDs, then we need to render a page, customize that page, and then also we need to update the information.
And that service that's handling all this, or this set of services, can you give some more details on where all this information is being stored? Is it in some kind of in-memory store or some more traditional database? What's going on there?
Sure. We are using AWS as our clouds. And then what we do, if we go from the layered perspective, we have CDN, we have WAF, and then we have application load balancer. Application load balancer get the request, and based on the path of that request, we are directing those requests with different services that's doing their job. For example, imagine that we are showing a CAPTCHA. So on the specific path that says API CAPTCHA, we kind of choose the target in AWS, means that those microservices that are responsible for this one. And because all of the services are behind this application load balancer, we have this capability of scaling behind the scene. So based on the scenario, we can scale and say, now the CPU response time or number of requests is high, CPU response time is high again. CPU usage is high. And then based on that one, we can automatically scale the backend, which is pretty important for us. Then these microservices will do a calculation. If it's needed, we touch a database. For the database, we are using, as you mentioned, in memory for some stuff that is more like a local, or I need a really, really fast one. We are talking about a couple of milliseconds. But also we are heavily using DynamoDB in AWS. That is a really cool high throughput database that we have. We have used it something, I remember that I said in some states we were talking about 100 or 200K TPS, transaction per second, for that one. So it gives us quite a really great capability to handle the traffic spikes.
It sounds like maybe the primary store of somebody's in the waiting room, you're keeping track of their GUID, where they are in line, all that information, it sounds like is in Dynamo.
That's correct as the backend, but also we use the cookies as well. It's hash. So on the client side, we have some information stored. Again, we do validation on that one. But from the database perspective, after the cache is hitting, it will be a Dynamo, and Dynamo is used quite heavily in this picture.
And you've mentioned how you have so many transactions per second. You gave the 100 to 200,000 as an example. Is there some kind of caching layer in front that's helping you handle that kind of throughput?
It's really dependent on the scenario. Yeah, if I want to say, yes, we have the caching layer as well, but Dynamo itself in most of the cases can handle this traffic. Creating a cache and creating a different layer will help in the scenarios, but what I actually experienced is that Dynamo itself can be seen as a persisted storage that is pretty fast. So we are talking about, if you have something like MySQL or other traditional database, for sure, there is no doubt that you need a cache in front of it. In Dynamo, when you are talking a Dynamo, at least in the scenario that you are worried about your data, because when you have a cache, then you need to be careful about the cache is stale or not stale, and all those itself will use some kind of a resources. But Dynamo doesn't. You have a scenario that can handle stuff. I can say, at least in our system, is 50-50. Whenever we can, we use that cache. But if it's not possible, Dynamo will handle for us. Or at least whenever a product comes and we are in the beginning state and we want something fast to the market, we can trust Dynamo for this scenario as well, without having the need for creating a cache in front of the microservices and Dynamo. So we can directly use Dynamo.
And the software that's maintaining the person's position in the queue and the software that's deciding when somebody should be removed from the queue, what is that written in and how does that part work?
Yeah. Our backend is mainly C#, not mainly, I can say 95% is C# in .NET. We have different services, as you mentioned, actually, you pointed out, Chris, that there is one group of services that's tracking the user place in the waiting room, rendering that one. And there is a couple of services that do the calculation of the waiting room itself, how many people should be redirected right now. And again, the complexity here is that we are promising to redirect X per minute. And then from number 100 to 100 plus X should be redirected in the next minute. However, in reality, those 100 plus 100X might not be ready to get redirected. Why? Because a visitor is looking at another tab or closes his phone. We want to get that flow. So there is some kind of calculation on that service as well. There are two different services. The other one look at how many people are ready to get redirected. And based on that one, we call that one open window, means that the window that we can redirect, we don't open. It is, imagine that the outflow is X. We don't say that open window is fixed X. We say it might go to 2X because there are not enough people to get redirected in the previous minute. So there is some kind of calculation on that one based on the historic data. So these two responsibilities are separate from each other, as you mentioned, but the language for all is C#.
If this is C# for the user-facing part, is that using a framework like Microsoft's ASP.NET?
Yes, it is the .NET Core that is hosted, and it is hosted on Linux servers.
And the part that is managing, I believe you called it the open window, how many users should be passed on to the origin or to the customer's site. I would guess that there's multiple instances of this service that needs to run. And if that's the case, how do they all manage this shared state they have to keep track of?
Yes. Each of these services that we discussed, user-facing, for example, captcha management or the flow managers, those services, we call them flow managers. All of them are behind load balancer, means that we have a couple of them. And based on the scenario, they can scale. We have two different scenarios right now that is working. One is that sharing the same storage, that could be a cache or Dynamo that I mentioned. So they look at the specific row and then they do the calculation here based on that row. So every of these services will say that, okay, I received this amount of requests for redirect. The other one says that I received this amount, and they put on the same row. And then one of the winner ones say that for the next minute, we will gonna redirect this amount. So that is one of them. The other scenario is that the server talk to each other through, in this scenario, I can say one of the technology we use, SNS in AWS, some kind of the update on that one, say that, okay, I received this, what I should do. And then everybody gets locally calculate based on all the information. So point-to-point messaging or a central storage to be able to communicate to each other.
SNS, it's simple
notification
service. Okay.
Exactly. Yeah. So in a simple way, it's like a message bus. You could say that, not a traditional way of defining that one, is that you update that one and it will update to all the nodes.
And something I believe I've heard about DynamoDB is that it's considered eventually consistent. Is that correct?
Exactly, yes.
How does that factor into your architecture? Does that ever become an issue?
Actually, this is a really interesting topic, and I would say that's one of the design practices that we have here is about this eventual consistency. I would call it actually the type of the business that we work and design a product for is really important. When I joined Qt before, I was working in kind of like an insurance or banking, you could say, system. In that scenario, when I moved to Qt and I started to develop the engine, and I was talking to a colleague, for me was, wow, you don't need to have the full transaction whenever you write. I said, for sure we don't, because, I need to support 100,000 requests per second. That's impossible. So that is a really important fact here. We don't need to have all the nodes know exactly at the specific point what is happening, because we have this tolerance. Okay, one node is behind 1 second, or 500 milliseconds, they can get updated after a second. So there is this factor heavily used in our design of the system. Not just this one, also the fact that, for example, doing backup from the client side, this is not all the same, it's like eventual consistency, and then backup, there are different things. But what I want to mention here is that in a specific scenario that we design a product for a specific business, there is some tolerance that we can use, tolerance of consistency, tolerance of time. Now for a human beings, 50 milliseconds and 100 milliseconds is not a big factor. So if there is a traffic really high, and in some scenario we cannot, in our design, we need to design for the failure. So if we think that there might our server get overcrowded, so why not doing a backup, for example, on the client side, or why not using the eventual consistency? So for us, it's used pretty well, and we didn't see any negative impact on the business part, I would say.
It sounds like it may be because of the part of the problem you're trying to solve. If you actually look at the customer's side, if somebody buying a ticket, for example, if there's no tickets left, but somebody's able to buy a ticket, that requires that kind of consistency. But since you're letting people into the place to buy and not actually doing the buying and selling, maybe that lets you sidestep that part.
You have a point on that one, yeah? If, for example, if we are 1 second behind or 1 second ahead, does not change anything. But on the ticket part, you cannot be like that.
In a worst case, maybe somebody is in the waiting room, they get to the part where they can buy the ticket, but the customer site will just say, well, I'm sorry, we got you in, but there's really no more tickets left.
Exactly. That is 100% correct. Yeah, because we use the time factor and we smooth the stuff, and that also the visitor got a good experience. And also, again, we are redirecting on the 10, 100, 200. That is also a normal scenario, and the visitor might see this one. Still, they had this experience of going through the process.
Yeah, on their end, that experience of knowing, okay, I'm in a line, getting some information of, okay, tickets are being sold. Maybe you're even telling them, hey, there's not that many left. So if they do get to the end and there's a problem, at least they had some amount of information on what was happening.
That's correct. Yes, exactly.
You mentioned CAPTCHAs as an example. Are there other parts of the system that are checking to make sure that this is a real person as you're going through this queue?
Exactly. This is a really hot topic, I think, for all the businesses nowadays, fighting with the bad actors and how you make sure that the right actor buying the product. We need to make sure right actor is waiting on the waiting room. And we fight with this one in different level. As I mentioned, there is one of them, for example, we say invite only waiting room. So users that had a good profile on the customer website are allowed to join a waiting room. So we give this responsibility and work with our customers, say that, these people has a good profile on your site. So sign a ticket for them. We let just people with the signature from you to join our waiting room. That is one way of doing it. We have also different partners to work with related to the bot recognition. Recently, we had this new product, we call it HEP, with one of the partners with Akamai bot team. We work together that they will try to tell us that, this traffic initiated from this specific session or visitor is a bad actor. That would be one of them. We can have also different challenges entering the waiting room. Some people saying that, okay, CAPTCHA is a friction. That's correct, is a friction. But if it can recognize who is bad and who is good, it is valuable not only for us, it's valuable for our visitor because, there is a limited number of the product wants to sell. The person that is interested in that product is willing to spend a minute to solve, for example, a CAPTCHA, but he gets the product, not the bad actor. So in our scenario, this is a kind of like a use case that we have. We have also machine CAPTCHA that shows that is not just a bot that trying to hit the endpoint. So it needs to have some kind of capability to solve that machine CAPTCHA. We say that make it expensive for the bots, so it's not easy for them to join the waiting room. We have also some kind of, we call it traffic access rules, a way of for our customer to customize and say for this specific IP address, I don't want to, they join the waiting room. So with the combination of these tools, we try to protect our customers and waiting rooms and real visitors from the bad actor to get the advantage. And I can say that based on the numbers, some waiting room, I don't know, in a specific businesses, there is more than 98% of scalpers or bot activity. So when we look at the data, how many it was blocked and how many got the QID, we issue this QID and then how many of them we blocked is more than 98%.
Yeah, so in that scenario, almost all of it is bot traffic. It sounds like, is that pretty common
yes.
for these events?
It is actually, in a specific interesting products. Imagine that there is a brand that's selling a specific cards, a specific sneakers, a specific, even in the tickets, because the bots will buy those and then sell it in the open market, for example, or really interested person wants to buy more than what it should buy. So we are seeing as a really driver also in the using the waiting room itself that brings the fairness on the queue. So not everybody that's putting the most requests buy it first. The example that you mentioned from the beginning, imagine I use my simple script that do add to cart fast and then script the whole process. So if it opens up now and I'm doing first calls, so I will get the product and the other cannot. But putting this kind of like a journey in front of that, it gives, first of all, to the bot protection providers to get enough time to recognize who is good and who is bad. It's not anymore transactional. Now you need to go through a journey so that intelligence behind this bot protection tools can help to figure it out who is good and who is bad. And also just by being fast or having a lot of compute power, you cannot purchase over a normal person that is interested on that specific product.
Okay, so the queue itself, that process of having a set time users join before the actual sale occurs, gives you this window of time, whether that's 10 minutes or 20 minutes, for you to to put users into a queue, but then while they're in the queue, try and determine, are they a real user?
Exactly. Now, actually, you pointed out to one of the main reasons that we did with the partner, not just only for us, also it was good for the other parties, the bot protection, because this journey gives the possibility and time. And also imagine in this scenario, you can put a CAPTCHA and people willingly solve that CAPTCHA. And who wants not solve it, then they don't get it. And the people that solve, they don't complain because, they are interested. They are more happier to prove that they are real.
Are there other examples? I think you mentioned there might be certain IP ranges that you decide, okay, these are probably bots. The other example was you present a CAPTCHA, they don't solve it, they're probably a bot. Are there other examples of things you look at when you're deciding whether or not someone's a genuine user?
Yeah, on the partner part, they have a lot of behavioral telemetry that mouse is moving, not moving, when I'm solving the CAPTCHA, how fast. There is TLS fingerprints, all those telemetry, we would say that signature from the client side, how it's behaving. We have also the part, for example, we know this endpoint should not be more than this amount of requests, or the request comes, should have this payload, or payload is not there, so it's not a correct one. And then also you can think of some kind of dynamic evaluation that you send a new version and then you change something there. The bots need to adapt to the new one. So if they are sending the old payload, you understand that this is not a real user because real user, they don't record and replay. So there is this capabilities because they have to go through this time and also the steps. So it gives us possibility to recognize between good and bad actors.
And I think you explained there's maybe two different parts. There's this partner part that's in front that has the bot detection. And then there's your own queue that has some form of bot detection. How do you decide what parts should be at the partner level and which parts should be done within your own application?
That's a good question. Right now, what we are thinking is that actually this needs to be woven to each other. It's not just two separate systems that working. So we need to provide some kind of information and then give it to the partner, and partner give us some signals that we react on that signals. So it is more like that. If they are separated, usually I can think of it, for example, just for a simplicity, think of a WAF scenario. You put a number of requests that goes to that endpoint and then you block if it's more than that. In this scenario, when we are doing in our ends, we know that a specific endpoint for a specific session cannot have more than 5. In this scenario, that is what we do. In the partner scenario, if these two are separated, is that partner knows what kind of IP ranges are from data centers, for example. They can block it before even getting to us. But the path that we are working on, and this specific HEP scenario, it is more like we provide the environment for the partner. They will give us signal for blocking. So we give the environment and time and all those specific about, we say that, this endpoint is important, look at this endpoint. Or this endpoint can be called multiple times, and then partner will detect that one based on our logic and then give us signal and we block. If that is not in picture, then we use our own specific bot detection tool. And we always say that, sure, we do help you on this one, but bring some kind of bot detector on the place as well, because it's always better to have 2 than 1.
Yeah, and the example you gave of potentially 98% of the traffic being bots, that it sounds like this almost becomes a requirement in a lot of cases where you can't sell anything unless you have some way of stopping bots.
Yeah. I would like to invite you in our product groups because you're actually mentioning this one, and that is exactly what we are saying, that this is part of our product that we need to provide. So for us, if we want to have one of our main slogan here is that, even I think is part of our kind of like a company code, is that we bring I'm sure, it is like we bring the fairness to the visitor user journey. And if we cannot prevent this bad actor to buy that product, so we cannot bring that fairness in.
Yeah, it's almost like you provide this queue for people to line up in, but if you can't also guarantee that that queue isn't just full of bots, then it's sort of like, well, what is this queue for?
True. That is a reason of the business. So it is really important for us to be able to handle that scenario. And it's not an easy thing. Yeah, it is like an arm wrestling. We try to innovate, the bots also try to innovate, and then we go head to head, and we hopefully we are the winner one, and we try to be winner one always.
Yeah, it's interesting that you mention how high the percentage of bots is, because I think there's a perception from a lot of users when they go to buy a ticket for a popular concert or a popular product. And when they have a bad experience and they can't get that item, like the site is frozen or it's just loading, I think almost universally people say like, well, the bots got all of them. That's why I couldn't buy it. And sometimes what a user thinks is not always correct, but it sounds like in this case, maybe it really is correct.
In some scenario, it is. Yeah, it is like how much compute power you have and you can access that endpoint. Even I saw a scenario that I was talking to kind of like a customers, and they wanted to be our customers as well. And it was like the bots will try to crash the server. So the normal people will just, they say, okay, I cannot buy, but then bots will go and buy. Or we saw a scenario that people put this stuff on the cart and block the whole other user cannot put anything because the system says that I don't have anything remained in my stocks. So there is a lot of scenario that is part of the bot stuff. And I have seen scenarios that when you open up the cell, it is gone after 1 minute, less than 1 minute, because all the bots is ready. So they are pulling or they are calling that endpoint. The time that it starts until I, as a user, click add to cart, they already did add to cart and they already went through the purchase flow. So everything is scripted. Do this, add to cart, go a purchase, put my information, ship the product here. So some part of it is the bots, most part of it, and also the other part is the amount of people are interested on that one and the server cannot answer.
For that second part where the bots are actually onto the customer's site and adding things to cart and checking out, Qt is supposed to be in front of that part. But for the customer's origin, for their own site, are there things that you recommend they do to account for that? Or is it more you think you put all that protection into the queue and then you don't put that into the actual origin?
No, actually, we are also part of that part as well. One of the things here is that the protection should not be on the main page. Imagine you send everybody to the queue on the main page, but add to cart is not protected. We have this way of you select where do you want to protect. And then if you just choose that I want to protect URL XYZ and then not add to cart XYZ, then actually you are limiting the real user, because real user go and wait and the bots will bypass the queue. So it's really important how your setup is and what is the protection plan that you have. I recall one of the scenario that one of our customers, again, one way of doing the cart updates, but not the other way around. So the bot figured out that they can do a purchase by doing another flow. Or imagine that you have two different websites that at the end will go and do a product. They had the older version, they forgot that one. So that was there. So this is pretty important that your ends should be protected. And also for us is important because at the end we are helping our customers and we are part of the user journey to bring this good user experience. And on the session website, on the customer, we have this static and also we have a dynamic way of making sure that this session is a valid session to do a purchase on that one. For example, customer can prevent the repurchasing. So every ticket can buy just one or all other scenarios from that perspective. But no, the answer is that we are responsible partially on the other of the whole user journey as well.
That's also an interesting point too, where you were saying how there's a lot of parts where kind of these main pages where you don't necessarily want to stop the user, because if I go to the origin, to the user's page, and I get blocked with like a CAPTCHA or something, and I'm not even at the point where I'm going to buy yet, I might just give up. And so there's this balance of I need these ways of blocking the bots, but at the same time, I don't want to make real users give up. Whereas the bots, they go, well, there's this CAPTCHA I need to solve, but it's a bot, so it's totally fine.
Yeah, that's correct. Also, this is also a good part about the waiting room. If you protect a specific part that is related to the specific interesting product, all the people that are shown a CAPTCHA on the waiting room, they are willingly to solve that one because they want to wait. So it's also another point that this makes sense for those hot items or hype items.
Okay, so if I'm a website selling products, maybe most of my products, they don't get a whole lot of traffic, but a new game console comes out and everyone's just hitting that URL, whether it's bots or people. So the rest of my site, I may not be putting those people in a queue because the traffic there is normal. I want them to be able to buy things normally. It's just that I'll put this queue in front of these specific products that I know are going to be a problem.
Yeah, exactly correct. And also, usually what a customer does, and what you sample said, it is actually, I was working with a customer related to that one. We have this two protection. We say that put a high outflow for all the other products, and when it's the high outflow, you usually do not see a waiting room because, your outflow is less than that. And then put a lower outflow for a specific product like the game console that you mentioned. And people wait until they buy, they solve the CAPTCHA, they go through that process. And then doing so, that's 24/7 protection with the higher outflow on the main. It will help you not crashing your main website because, the time that you want to sell, maybe people get confused and go to all the other part of the website. So it still is a high traffic, but they recognize that, okay, I don't want to do that now, or, they continue. But in a specific product, you go to another queue with a lower throughput and all the randomization and CAPTCHA because you want to buy that product.
So something about Hewitt is because it is in front of a lot of the interactions that a user is going to have, it's very important that it stays running. And if it goes down, then you're really stopping the customer from being able to sell whatever it is they're trying to sell. Given that every application is going to have incidents or downtime, and so I wonder if you can talk through maybe an example of when you had an incident and what the cause was and how you dealt with that to address it in the future.
Oh my God. This is a really hot topic, hard topic. Yeah, first of all, it is part of our, when we sit down together, developer and the department, we say that the main one thing if you should do is being a reliability. Reliable product is what we need to do. We are 24/7. As you pointed out, this is the most important part. And then when you say, okay, is reliability important, then you design by that one. Design for failure, simplicity is really important. Don't create a complicated web services they cannot scale. Don't do a lot of I/O. Don't call the database if you cannot call the database. Do a load test, all those stuff, preparing this system that is highly available, a reliable system, and can scale. But as you mentioned, there is a scenario that you might get some kind of incident on that regard. What we have is that we are designing some part that's possible to move the infrastructure across different logical boundaries. What does that mean? It means that imagine the waiting room is here, and then the service behind that one is getting huge DDoS attack. And that endpoint, that IPs or load balancer even cannot stay alive because whatever server you add, it will crash in the place that the TLS handshake will crash. So something like that, or the traffic is huge, the whole network cannot. What we kind of like do is that, okay, can we move this traffic to somewhere else, or can we move the other kind of like a good traffic to somewhere else healthy? And that was actually one of the incidents that we work on that one. And we were really on the really huge load until our WAF, and we update the WAF. We pointed the whole traffic to somewhere else, the good traffic. So the bad traffic was hitting somewhere. It was not issue. There were, even the server failing, it was not causing an issue for the good traffic, at least. And also this is hard how you recognize who is good and who is bad. But playing with that endpoint, that you at least diverge the traffic and bring up new server that's now my server here is down. Now I will up a totally fresh server, can handle more, all the deadlocks, if ever anything here, all the stale connection will be a new one that created in the new environments. That is how we try to handle this one, you would say.
In that example, you're saying you got a really large number of load. Can you just give an example? What is that load? What's considered large from your
I'm talking
your
about when the traffic spikes comes, the traffic spikes should gradually come into the system. Yeah, if it's the new users, and usually our system is over provision and it can handle, 10x factor. And then your scaling when it's come to picture take 1, 2, 3 minutes to come up servers. Yeah, pretty fast. So you are preparing for 10x. Your server can scale every 2 minutes. You understand that, okay, traffic will come 2x times more. So until it get to 10x, you have already new servers in place. But imagine that the traffic goes from 100,000 to 100 million. That is like how 100,000 10 times and then 100,000 times more. Yeah. So the system cannot scale that fast in that regard for this specific scenario that I'm mentioning. When the server comes up, until they load and try to get, they die again. So what we do is that we redirect the traffic to the new environment, totally create a new environment with, imagine that's 100 servers. And when they are in a stable situation, we point the traffic to that environment. So doing that will help us to get rid of that starting point, at least in that scenario we had. Until the server comes up and the hash get warm, there was some time that they would crash because the traffic wouldn't let them to warm up. So we warm them up before putting them behind the load balancer, and then we directed the traffic to them. That was something pretty complicated on that scenario.
When you're talking about warming up, is that the runtime, or what part needs to be warmed up? It was
more like, in this scenario that I'm specifically talking about, it was imagine related to the, let's say about the whole, what is the word for that? How much visitor session are trustable, yeah, for the bot protection. You create this cache that's, understand this specific visitor has this level of trustability, the other one has this level of trustability. We would fetch this information inside the servers to be able to start fast on that scenario. And it would take something like 1 minute or 2 minutes to be able to warm that one up. The design, we changed it later on, but that was how the design was done. So when we would add a new server, it would take 3 minutes for that server to be able to serve the responses. So there is already a huge traffic. This server will come up until they be able to handle that traffic. At the same time, they needed to update their memory with the data of the visitor score in the memory. This would cause the server crashes themselves. What we did is that we just waited. We brought them up without adding them behind this huge traffic on the load balancer. So that load balancer was safe, no traffic. They came up 3 minutes, the data was on the servers, then we pointed the traffic to those. It caused the system comes up, but it was not that easy that I'm explaining because it took us some time to make that decision pretty fast, because if the end user seeing the CAPTCHA cannot generate it or something like that, it will prevent the events go forward. And as you mentioned, it is like we call it critical incidents when it's talking about the visitor experience, because it means that we are doing a disturbance of the customer sales on their most important days. That is a really hype sale going on.
Oh, I see. So that warm up is your services when they first start, they need to retrieve data, maybe from Dynamo, maybe from some other store, to store in memory to be ready to process the users in the queue. And your production instances, they were getting too much traffic to even get to that point. Like you would try to auto scale, create a new instance. It tries to get the information it needs so that it's ready to handle traffic, but it's getting too many requests. So it just crashes. I see.
Exactly. That request to getting the data plus the request of answering means that we were having a thread starvation. So I start a thread to get the response from my cache because all my threads was answering the request coming. There were no thread to getting the answer from that storage part. So that was causing an issue for us.
I see. So the amount of traffic increased much faster than you anticipated.
Yes.
It's not so much that there was 100 million connections or 100 million attempts. It's that it went from maybe 0 to 100 too quickly. Yeah.
Yes, that was like the case. Again, we could handle that one if the system was designed not having that cold start. And that was also what we changed on that scenario, that, okay, if you don't, that is now we go into that eventual consistency part again. For example, in the revise of this one, we said, okay, if you don't have information about the score, maybe it's not really important on the first request. Just wait and make that decision maybe on the 10th request until gradually you got the data that you needed to make that decision. Don't wait that, okay, you don't have the data, you need to first get warm. No, you can answer the client and little bit say that, okay, I don't have a data, sorry, wait for me until I get my data, instead of waiting to get that data and then answer.
It's almost like a form of, I'm not sure if this is the right term, but graceful degradation of I can't get the most current information or the best information, but I'll at least do something with what I have.
Exactly. And that is part of the system design. I would say that is the most important part. You look at the business, that is at least what I learned during these 10 years of handling these huge traffics with all the limitation we have. At the end, we have a limited resources, how fast they can scale. At the end, you need to find possibility of tolerance in the business. So I can answer to the client said, make it next. Instead of I block this request and show the person that you are a bad request, I can do it in the next time. Anyway, the person is waiting on the waiting room, so I don't need to act at this request, a specific one. So as you mentioned, kind of like a fallback, not the back-off scenario in this scenario.
And this incident, I'm curious, how did it get handled in terms of, did somebody on your team get a notification that there's a bunch of users trying to get through the queue? Do they get notified, and then do you all get together in some kind of chat room? How does this get managed?
It is actually like what you are mentioning. We have this dev duty team, or the people that's always, some people has this alarm on the phone. Their phone needs to be on. They get notification. And then when they get this notification, we have also alarms from our load balancer, how many traffic we have per minute. What does it mean normal? What doesn't mean normal? Because, you might expect this kind of traffic because there is a really hot event, and then that is a normal traffic. But then when it jumps in 1 minute, going from 100,000 to 100 million, for example, you understand something is wrong. And then we have also a response time and 5x's. We monitor all those stuff. So when there is a huge 5x's, or when you have a high latency, then you understand system is not healthy enough. So the healthy is there. And then when you get this one, you try to look up what happened in this scenario. We have this incident group that the room will be created. Somebody get the incident management to inform the stakeholders that, in this scenario, actually, it's really get escalated to the higher level. That's right now, there is this huge amount of traffic. How many customer, how many end user are affected? How many customer are affected? And it's not a funny days, or funny times. But different people, like a platform people, look at the health of the load balancer, what we can do. One group of our colleague brought up the backup environment with warm-up server. When that was ready, then we pointed out to the new environment instead of the old environment. So we updated that one. We had designed system in a way that you can diverge the traffic to the another environment. So that really helped us. So generally, we have this in our system, that the system should be resilient from that fact that we can move the traffic to another server. That helped us. Yeah, but it was pretty tough, I would say, that because when there is this, it's not just that specific cells that might get affected. Also, it might affect the other cells as well, which is not the best situation.
And starting from getting that notification to resolving the incident, it sounds like you have to determine what went wrong. You have to create this other environment. You have to configure it to use that environment and make sure everything is working. Can you give a sense of how much time that is between knowing there's a problem to the resolution and what the end user actually saw or experienced during that time?
It is depend on the scenario. In this specific one, I think that as far as I remember, something between 30 or 40 minutes it took us to be able to put system totally on the healthy scenario. During this time, in the beginning, couple of minutes, we had quite high amounts of the failure. In the JavaScript side, what end user sees doesn't, again, this one is part of a design that is, we call it again, backup or fallback, or, on the client side, because our JavaScript make a call to the server cannot answer. They just say, okay, wait more. That is also a design practice that we do. Again, this is a possibility that systems give us that, okay, a user is engaged. He wants to redirect right now. What about he redirects 2 seconds later? Or what will happen if the data that is shown, your turn will come? For example, imagine I'm showing this, you are number 100, but I should show you are number 98. It's not a big deal because I couldn't update the data. So gracefully, I would say that, okay, on the client side, I can do graceful and show them the old data instead of the most newest data that is their turn. That was most of the developer. There is this, what will happen on the first request. In that scenario, we had some user that they saw 5xx's in the first 5 minutes until we figured out what the system because also system needs to understand that now you should not return exactly what you were returning before because you are under the load. So during those time, we were showing some kind of 5xx's from the server. That is the worst for us, especially if this is the first page, because if the first page get that one means that you will be presented with this bad user experience. Although when the user presses a 5, he gets the page, but just, imagine that you are waiting for a ticket and suddenly you say 5xx something, something has happened. Some 5xx's was returned to the bots. We are not angry with that one. But anyway, to understand after that, after post-mortem, we did also see that how many of them was for, most probably for the bad actor, because we had the request per IP address. We understand that, this is fine. This is returned to the bad actor. The other one is more for the real users. But we had some degradation, especially during that 5 minutes. Some of the requests failed because, again, you are behind the load balancer. If your request hit the unhealthy server, then you get the issue. If it hit the good server, you are fine with that one. Those that they are not pressing F5 or they already determine that what is the state, and on the client side, we were having gracefully kind of like not showing any issue.
Yeah, just showing them in the queue.
Exactly.
And maybe the position's not changing, or maybe it's behind. But to those users, they may not even be aware something is happening.
Exactly.
That you're busily scrambling in the background trying to see what's happening. Yeah.
That is actually part of, again, this is part of a design that we need to, because, the client side, if we were not designing in a way, then client side also might show a bad experience. But why doing that if we have this possibility? So, and again, this is also part of our design that we say that the first request needs to go, for example, from a CDN, that does never fail. So even if I'm not returning a response, maybe I just show them, please wait, we are doing something. So this is what we learned also after that one, that this is the direction we need to go. Never show the failure if you can recover in a short time. Because at the end, if I'm waiting 1 more minute, I'm fine. But if I'm seeing, everything is on fire, even I might leave the queue and do not do my stuff. But it was an intermittent issue and it's happened for everybody. Yeah, you cannot be always kind of like without breaking undercover do the things.
And is the design such that if the user was on the page that just looked like they were in the queue normally, if they open the developer tools and they look at the network tab, are they actually seeing there's requests being made that are returning 500s?
It could be. We can also, some stuff we can, for example, if we don't return a JavaScript error, you don't see it in console. But if the request fails, you can see in the network tab. And I think actually it's fine totally. We are not hiding that something has an issue. We are hiding the bad user experience. And I think that is still is a valuable thing on that one.
for the normal user, that's all that matters is what they see. And I think the opening the developer tools is more just if you're a curious developer and you're trying to get tickets for this event and you're like, well, what's going on? Then you might see some hints there.
Yeah, exactly. But at the same time, we are saying that we don't, for example, redirect them without their turn in this scenario. What we do is that you need to wait more than what you should because all the other people also needs to wait anyway. Right. So if we were, in for example, in failing OpenImagine in this scenario, I would say, okay, just redirect them. That would be also another design. In some scenario, maybe that is the best design because you don't want to make people wait more than what they should because 1 minute is important. But in this specific one that I'm just, okay, if I'm waiting like 25 minutes, okay, I can wait 26 minutes. There is nothing, again, part of the business, how that is. Business, I call this one business tolerance. When you understand that business and user flow, you can design it for that specific business.
And in this specific case, earlier you mentioned how the amount of traffic is spiked a lot more than you expected. You also earlier said how in some cases, 98% of the traffic is bots. In this particular example, was most of the clients getting these errors and trying to hit the site, was most of it bot traffic in this case?
That was correct, yes. But again, it's pretty important that because at the same time, you have another sales going on and your infrastructure, anyway, some part is related to each other. You should just do it in a way that isolate this specific one. Do not mess the other one. And then in this one, try to isolate the bad with the good one. So this is also part of the design of the system that needs to be able to do that one.
And if people want to learn more about what you're working on or what's going on with Qt, where should they head?
We have this Qt.com. There is all the resources that we have. We have also on the GitHub/Qt, we have all the open source part, like connector are there. And we have also a lot of podcasts as well. Like you are doing it professionally. We are also trying it to do on our end. And we would be happy to hear from all the audience.
Very cool. Well, Moji, this has been an interesting conversation. Thanks for taking the time.
Thank you. And it was nice to be here with you.
This was Jeremy Jung for Software Engineering Radio. Thanks for listening.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.